While the quadratic formula works great, sometimes it's too computationally heavy for what we really need. An example is this problem. Whenever we have a case where we don't have a separate x squared and x term, we don't need to use the quadratic formula. For this problem, I'm going to solve it by undoing all of the operations to isolate the x. So I'm going to start by adding 4 to both sides, since this minus 4 was kind of an outlier. Once we have 7 times x minus 3 quantity squared equals 4, the next thing I see is that this 7 is multiplied in. Let's divide it out. That gives us x minus 3 quantity squared equals 4/7. At this point, we need to undo the squared. We do that by taking the square root of both sides. Something though about taking the square root of both sides, if I can do a related example of x squared equals 9, let's say, there's actually 2 solutions here. If I just take the square root of both sides, I should actually have x equals either a positive 3 or x equals a negative 3. Both of these numbers, when squared, result in positive 9. Going back to the problem at hand, what this means is when we take the square root of both sides, we have to remember to have a positive and negative version of the answers. The square root of x minus 3 squared results in just x minus 3, or the absolute value of x minus 3, which results in positive or negative square root of 4/7. Our last step is to add 3 on both sides. I added it in front of the radical because that's how I most frequently see it in books. This is the exact answer. Frequently, especially in this class, we want an approximate answer. You can find the approximate answer by plugging into your calculator 3 plus square root sign 4 divided by 7. And then do the same thing except with minus. In this problem, that works out to be x is approximately 3.7559 or 2.2441. Thank you.